this video, we are going to learn what a stationary point is. A stationary point of a function is a point where the derivative of the function is equal to 0. And we know when the derivative of the function is equal to 0, that the gradient of the tangent to the function is equal to 0. So in other words, the gradient of the tangent to the function at stationary points are always equal to 0. Okay, let's take an example. For example, consider the following graph. So the graph goes like this. Okay, and we can see that the tangent, the gradient of the tangent is equal to 0 when we are here. So here we have the tangent. Or when we are here. Just on those 2 points, the gradient, the derivative of the function is equal to 0. So when I write down here the derivative of the function, on those 2 points, the derivative of the function is equal to 0, and here as well. And we can clearly see that this one here is a maximum and that this one is a minimum. So this one is called a maximum turning point. And this one is called the minimum turning point. We see on this part of the graph that the function is increasing. So when the function increases, we can say that the derivative is positive. So on this part, the derivative of the function is positive because the function is increasing. Here, between the two, the function is decreasing. When the function is decreasing, then we can say that the derivative of the function is negative. And here we see again that the function is increasing. When the function increases, the derivative of the function is positive. So when we create a sine table here, for some x values, here we have the derivative of the function. And we have, for example, the maximum turning point at x1 and a minimum turning point at x2. We know that at a minimum and a maximum turning point, because those are examples of stationary points, the derivative of the function is equal to 0 there, because we set that. Let me write that there properly as well. Okay, and here we see that it's positive. So the derivative is positive. Here it's negative, here it's positive. So when the derivative is positive, we are increasing. When it's negative, we are decreasing. When it's positive, we are increasing. When you first increase and then decrease, then you have a maximum turning point. When you first decrease and then increase, then you have a minimum turning point. So here, a maximum turning point, and here we have a minimum turning point. So a stationary point can be a maximum turning point or a minimum turning point. But there is one more option. For example, consider the following function, like here. So this is f of x. So on this point here, we can see clearly that the tangent is horizontal, so that means that the gradient of the tangent is equal to 0, so that means that the derivative of the function is 0 there. So if I write here the derivative, that means that here the derivative of the function is equal to 0. And on this point here, we don't have a maximum turning point. We also don't have a minimum turning point. We call this point a stationary inflection. Okay. We see that on the left-hand side of the stationary inflection, the function is increasing, sorry. And on the right-hand side, it's increasing as well. So if we want to do the sine table, on this point, let's say that we have a stationary inflection at x1. The derivative of the function is 0 when x is equal to x1. Before the x1 it's positive, and after the x1 it's still positive. So the function is here increasing and here also increasing. In that case, so when the function increases before the stationary point and it also increases after the stationary point, then we can say that that stationary point is a stationary inflection. Okay. There's also another possibility. Instead of increasing on both sides of the stationary point, it can also decrease on both sides of the stationary point. So let me write the sine table of that one. And here we have f of x. So in this case, here it's 0, but it's negative. So the derivative is before the stationary point negative and after the stationary point negative. So we decrease it. It's decreasing here, it's decreasing here. So that means that here we also have a stationary inflection. So the third option here is stationary inflection. So when we have a maximum turning point, the graph should look like this. Something like this. When we have a minimum turning point, it should look something like this. When we have a stationary inflection, it has to look like this. Or in the second case, like this. Okay? Now we learn one more thing. We said here when the derivative of the function is positive, then f of x is increasing. When it's negative, then it's decreasing. Let's write that down. So when the derivative of a function is greater than 0, then we say that the function is increasing. When the derivative of a function is lower than 0, then we say that that function is decreasing. And when the derivative of the function is equal to 0, then we say we have a stationary point there. And this stationary point can be a maximum turning point or a minimum turning point, or it can be a stationary inflection. And that depends on the sign table. Depends on the sign table. Okay.